Hello everyone, welcome back. For today's video tutorial, I will be introducing a new sensor that is TCS34903. And to have a better perspective regarding the sensor, let's visit the website that is controleverything.com, and here we have to search for this sensor and let's see what we got for this sensor. And it's a color light to digital sensor, as you can see, and these are some of its more features described here. Also, you can purchase the sensor from this website. Well, I will be interfacing the color sensor TCS34903 with a Raspberry Pi and a Java code. And to get the Java code, let's go to Resource tab, and here comes the Java code sample. Now you can also download the code as a zip file from here. You can also have the code from github.com, and the repository there is Control Everything Community. Now let's have a look over the hardware connections. We need to set up the sensor, and let's see what we got there. In the hardware section part, first of all, the requirement is our color sensor, that is TCS34903, and this here is a Raspberry Pi, and these are the GPR pins of the Raspberry Pi. Now this here is an I2C Shield, and it's available on the website controleverything.com. The reason we are using this I2C Shield here is to make easy connections with other I2C devices, and for that, gently place the I2C Shield over the GPR pins of the Raspberry Pi, and then we are done with this connection. Now this here is a connecting cable, and make the connection of the cable and the sensor, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and same for the I2C Shield. Next, we require a micro USB cable just like that to power up our Raspberry Pi and gently insert it over the power jack. The last part is to provide internet connection, and for that there are two ways, and first way is an Ethernet or LAN cable, as you can see, and gently insert it over the Ethernet jack. Next, we require a wireless nano USB adapter in case if we don't have the LAN cable or the Ethernet cable, and it might save your day also. So we are done with all the connections we need for this setup. Now what do we require is to look over the code so that we can interface this with our sensor. Now for the interfacing part, what do we require first is to log in to github.com, as you can see on my screen, and here we have to search for the repository that is Control Everything Community. As you can see here, we have to search for the sensor, and what we got is a color sensor, and this is a Java code. But let's have a look over the instructions. First, we need to fulfill. It says that we have to download and install Pi4j library on the Raspberry Pi, and pi4j.com is the link from where we can have the installation, setup, process, everything is there. Please note it down carefully. And after that, this is the command for the compilation, and this for the running of the Java code. Now get back to the Java code so that we can explain it better. It says that .java extension, and as you can notice in the code, we have imported some of the Pi4j libraries here, and we have created a public class named TCS34903. And bus.getDevice is the address where we are having 0x39. That's the I2C address of the sensor. In the writing section part, we have to set wait time register, as you can see 0xFF, and it's 2.78 ms, and 0x83 is the wait time register where we are sending the command, and 0xFF is there. After that, we are able to enable access to IR channel. It says that the writing command is here, that is 0x60 is the register and 0x80 is the command. After that, we are going to set A time register to 0x00, maximum counts is 65535, as you can see, and 0x81 is the register and 0x00 is the command. And in the last part, we are having power on, ADC enabled, wait enabled, and the address of the register is 0x80 and the command is 0x0b. Then we are going to retry the data back from the sensor. That's the reading part. As you can see, we are reading 2 bytes of the data from the address, that is 0x94. It's the IR data, and here comes the conversion of the data takes place. As you can see, it's according to the data sheet details provided for sensor TCS34903. Similarly, we have 2 bytes of data from the address 0x96 for red, and here it's green from the address 0x98, and from 0x9a we have blue, 2 bytes of blue, as you can see. Here comes the calculation of the luminance and the formulas being provided on the data sheet. After that, all the calculations what we require is to show the output data on the screen. As you can see, we have the IR luminance along with the red, green, blue color luminance, and the final ambient light luminance is at the bottom. And all the relevant values for luminance are shown in lux unit, which is the common unit. Now what we require is to show the practicality of this code, and let's see how the sensor responds and works. Now in the environment part, for the working environment part, the first step is to copy this entire Java code as you can see on my screen and open up the terminal of the Raspberry Pi via internet, and here we have to create a new file as you can see on my screen with .java extension, and here you go, paste the entire code here, and after that we have to save the code as you can see on my screen, and this is a command to compile the code as you can see on my screen, and here you go. The code is being compiled. Now this is the command to run the code. As you can see, we have the IR luminance, red color, green, blue color, and total luminance. And when I'm running the command again and again, you can see the values are almost constant because there is no interference regarding the light intensity that is falling on the sensor. But when I place an object source over the sensor and run the command, you can see the change there. It's decreasing because the light intensity is decreasing, and for that IR, red, green, blue, and total luminance is decreasing. But when I place a light source near the sensor, you can see the increase in IR, red, green, blue, and total luminance. As I move the light source near the sensor, the luminance increases for all the values for IR, red, green, blue, and total. So this is how the sensor works, and let's see what are the applications and benefits for the sensor TCS34903. The TCS34903 device provides color and IR light sensing. The color sensing provides for improved accuracy, lux, and color temperature measurements typically used to adjust the backlight intensity and correct the display color gamut. Additionally, it can be used for light source type detection as it reports the IR content of the light. The applications include ambient light sensing, color temperature sensing, industrial process control, and medical diagnostics. Now this sensor is available and can be purchased from the website that is called controleverything.com, and you can get the code from the source tab from this website. After that, you can download the code as a zip file from this very site. Also, you can have the opportunity to download the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make any clarification if you have, and for further queries you can reach us on controleverything.com, and for comments you can post your comments on community page. For articles and blogs you can have a look upon instructables.com, and to subscribe more video tutorials like this you can go to our YouTube channel. I hope you enjoyed this video and have a good one yourself. Thanks a lot for watching.